All right, so a 2010 study conducted by the National Center for Health Statistics found that 25% of U.S. households had no landline service. This raises concerns about the accuracy of certain surveys as they depend on random digit dialing to households via landlines. We're going to pick 5 U.S. households at random. And it says, what is the probability that all 5 will have a landline? Okay. Then it's, well, let's just start there. So for part A, let me see if I'm connected. Yep. So for part A, what's the probability of them all having a landline? So they're going to pick 5. So 25% do have it. Well, let's think about this. So it says 25% do not have a landline. So that means that 75% do, right? That's because they're the complement. Where does that come from? That comes from 1 minus 25%, which as a decimal is 0.25, so that would give me 0.75. So how do I figure out what that is? So here's where you got to think about this. To find the probability of this, I know that I'm going to do something with 0.75. That's the probability of when I draw one person, I'm going to get, if I just did one person, I got a 75% chance of getting that person with the landline. Now it's saying for all 5 people. So that means I'm going to multiply the probability. So I'm going to say 0.75 for the first one. I got a 0.75 probability for the second one. I've got a 0.75 probability for the third one. Because the question is, what is the chance or the probability of all 5 being a landline? I ran out of space there. Let me give myself a little bit of space here. Or you could just write it this way. You could say 0.75 raised to the 5th. Now, if we plug that in our handy-dandy calculator, let me get my calculator going too. Where's that at? Oh, shoot, I don't have it loaded. That'll just take a second to load. If I plug that into a calculator, I'm going to get about 0.237 or 23.7% probability. Okay? Any questions on that part A? Now, I want to point out that we did that because they want all 5 of them. You're going to see that this is going to be a little different now. So now it says, what is the probability of at least one of them not having a landline? So now this is a different question. So I'm going to write this a little more formal. There's a couple ways you could do this. You could say, what's the probability? So you do it like this. The probability of at least 1, no landline. Well, what's that going to equal? That's going to have to equal 1 minus all the landlines. Right? So we're going to go with the complement. So there's a couple ways I could do this. One is I could say at least one. That means that 1 doesn't have a landline, or 2 doesn't have a landline, or 3, or all 5 doesn't have a landline, which is the complement. So I'm going to say 1 minus the probability of all of them having a landline. Now the reason I do it this way is it's a little bit easier, because I just figured out what that probability was, didn't I? So I would say 1 minus the probability of all of them being a landline, and that would be 1 minus this 0.237, which is equal to 0.763. So you got a 76% chance that when you go to do this, at least one of them will not have a landline. What's the probability that at least one does have a landline? Okay. So this would be, for part C, if at least one of them has a landline, then that would be equal to let's think about this. If at least one has a landline, so that means I could have 1 that has a landline, I could have 2 that has a landline, I could have 3 that has a landline, I could have 4 that has a landline, right? But really, it's the complement of no landlines. Anything, so if I know the probability of having no landlines, the complement of that is at least 1 having a landline, or 2, or 3, or 4, or 5. So I could say this is the probability, it's the complement. So I would say 1 minus the probability of no landlines. And we know what that is. The probability of no landlines, is 0.25 raised to the 5th, which if you plug in to your calculator, it's a very small number. So it's got like a 99.9% chance. Does that help you guys? Okay. So the trick there is basically we could calculate the probability of 1, the probability of 2, the probability of 3, and then we'd have to add them all up, and it would equal 0.99. But it's easier just to do the complement. So just by show of hands, did you guys try to add them up? Like calculate the probability of 1, calculate the probability of 2, and then add them up? Did anybody try that? You get the same. You'd get the same number.